Hello and welcome to the channel. In this video we will talk about linked list. Let's say we have some numbers 2, 4, 9 and 8 and we want to insert this number in a list. So the first method that we will think of is to define an array of size 4 and put these numbers in there. Now let's say we want to input some another number into this list. Now this is not possible. To do this we have to redeclare the array with size 5 and then only we can insert this. To tackle this problem we take the help of linked list. Now linked list consists of a node. A node have at least two parts. The first part is the one that carries the data and the second part is a pointer. So now if we want to create a list using linked list, what we will do is we will first create a node with the first element. So here it will be a data and in the second part this will be null, which means this is a pointer that stores nothing. So the first node is called a head node. Now the next element in the list is 4. We will create another node with 4 and the pointer will be null. Now let's call this n1. Now since the element in n1 is the second element of the list, so the pointer of the head node will keep the address of n1. Similarly we can create other nodes like this. This is n2 and this is n3. Now this n1 will contain the address of n2 and the pointer for n2 will contain the address of n3. And now since n3 is the last element of the list, this will point to null since it doesn't contain any elements after it. So now if we want to insert something, we can simply create a node with the new data and set this pointer to null and let's call this n4. Now what we will do is we will point the pointer of node n3 to contain the address of n4. In memory, if we want to store some array, it takes a contiguous block of memory. But if we are storing a linked list, it can be at any location in the memory, given that each node have the address of the next node. In this video, we will try to write a programs which will help us to traverse the list, insert the element and delete the element from the linked list. Now insertion will take place at beginning and ending and after a given position. Now to create a node we will simply create a structure with let's say struct we will have a data here and we will have a pointer and we'll call this pointer next. This pointer will store the address of the next node. Let's call this struct node as node with the help of type def function. Type that keyword. We'll write here node again. Now we will write a function that will create us a node. For that, since the function will return a node data type, we'll write here node, and since it will be a pointer, we'll put a asterisk here followed by the name of the function. Let's say we will write here create ll, or we can write create node, and here we'll pass the data. Now to create the node, we will use the node structure, and we will call the node, let's say n, and we'll write a malloc keyword here so that we can reserve the space of the type node, and here we will write node star to typepass the whole thing. Now we can say n of data is equal to data, and n of next is equal to null, and we will simply return n. Now we can also create a function to traverse the list. Since we will just be printing, the return type will be void, and we will write here, let's say get ll. We'll pass here the head node. It will be a node star head. Now what we'll do is we will create a copy of this head node. We'll create a pointer, let's say current, and we will say that this is equal to the head node. Now we can write a while loop to print if current of next is not equal to null. We will keep on printing the value. We will write here current data. Now since we want to increment the current, we will set the current equal to current of next. Now since the last element will also have the pointer pointed to null, we need to print the last element too. So we will just copy this line and paste here. And that's it. Let's try create a node. We write a node star. Let's create a head pointer. We'll write create node, and let's say we'll give it the data 23. To print it, we will write get ll, and in the argument we'll pass the head pointer. Let's save this. We'll compile the code and we will run it. Now it says 23, which is on the only element present in the list. Let me give a \n here to make things more beautiful. Alright, now we'll try to write a function which will insert elements at the end of the linked list. First we'll write the return type of the function, and we'll give a function name, let's say insert, and inside this we'll pass the head node. We'll pass the data that we want to insert. Now we will copy the head pointer once. Now we will create a new node with our create node function, and we'll pass in the data which is in the argument. Now we will just traverse the node using the same logic that we applied earlier. Next is not equal to null, and here we can write current of or current equal to current of next. Now when this will reach null, it will come out of the loop, and then we will set current of next equal to new, and we will just return the head node. Let's create a node here. We'll write insert, and let's say we write it 54. So we can insert another number also here, let's say 4. We will save this, we will recompile. Okay, there is some error because we didn't write the head pointer here. Now let's save this, recompile. Another error, we will go to line 10, we will change this. Let me clear this, recompile and run, and things work fine. We are able to insert the elements at the end of the list. Now let's create a function to insert the element at the beginning of the list. We'll write the return type here followed by the name of the function, insert beginning, and we'll pass the similar arguments, integer data. Now what we can do is we can create a new node. For that we will say node star new is equal to create node, and we will pass the argument that is the data here, and we can simply set new of next is equal to head. Now instead of returning head, we will return the new node here. Now let's try to insert at the beginning. We will insert a number, let's say 65. We will save this, we will recompile and run. Now 65 is inserted at the beginning of the list. Let's try to insert at any given position. First we will simply write the return type and name of the function. We will write insert at a given position. We'll pass the argument. The first argument will be the header node, second can be the data, and third can be the position. Let's visualize it first. Let's say this is a node, and this is a node, and this is a node. This contains the address of this, and this. Now we want to insert a node at after position 1. So what we can do is we need to keep track of two things: a pointer pointing this node and a pointer pointing this node. If we call this pointer as previous and this pointer as current, we can simply set previous to point to this node and this to point to current, and we will be able to insert it here. In order to do that, let's create a node that is to be inserted first. We will write new equal to create node and we'll pass in the data. We will copy the head node and we will create a previous node here. Also we can create the variable to track the position. Now in the while loop we can say that while current position is not equal to the position after which we want to insert the node, we can simply set the previous node to current, and we can increment the current such that current is equal to current of next. Also we need to increment the position. We will say current position plus plus. Now when the position is reached, we will simply set previous of next is equal to new, and new of next is equal to current, and we will return the head node. Let's try to insert something. Let insert position, we will pass the head node, we will pass number less than 99, and we will say we want to put it after the number 23. So this is the 0 first position. Boot here 1. Let's save this, recompile and run. Alright, it puts it in a given position. Let's see what happens if we give 0 here. We'll recompile, run, and it goes to an infinite loop. To tackle this, we will simply change this to position plus 1, and now things should work fine. Alright, now it inserts after a given position that we initially planned. Now if we give 1 here, save this, recompile and run, now it works properly. Now this is for insertion. Let's try to delete an element from the beginning. We will first write the return type followed by the function name, and we will pass the head pointer here. To delete from the beginning, we can create a new pointer to track the current, or else what we can simply do is return head of next. the next pointer of the list. And if we try to delete now, we pass the head here. Let's see if the algorithm is correct. We should have 65 removed. Let's save this, compile and run, and now 65 is removed. If we run this again, 23 should be removed. Alright, I removed this one part. Now let's create another function to delete from the end. We'll write a node head pointer. We will create a current pointer to track the location. We will write node star current, which will be the copy of head. Now we can simply say while current of next is not equal to null. Also here we need to keep the track of the previous pointer, so we will create a pointer, let's say previous. Now we can say previous equal to current, and we can write current equal to current dot or current dash next. Now we can say previous of next equal to null, and we will return the head pointer. Let me write head here, and we'll write delete end. We'll pass the head pointer. Now if this is correct, we should have 4 removed. I'll save this, recompile and run, and now 4 has been removed. Alright, let me insert some new elements at the end. Let me give this as 1, and let's say 60 or 78. Let me rerun it. Alright, it works. Now let's try to delete it or after a given position. We'll simply write the return type of the function, delete at a given position. We'll pass the head pointer, and we can pass the position. Here also we will create a current pointer, which will be equal to head. Also we will create a previous pointer to track the location of the previous node, and we can create a variable for the current position and name it as 0. Now we can simply say while current position is not equal to position plus 1, we will set previous equal to current, and we will write current equal to current of next. We also need to increment the current position. we'll write current position plus plus. Now when the position is reached, we'll simply say previous of next is equal to current, and we will return the head node. Now if this is correct, we'll write delete at position. Let's say we want to delete 54, that is after position 1, so we will pass here head and we'll write here 1. If this is correct, we should have 54 removed. Alright, we can change this to previous current dot next. Let's save this and recompile. Alright, now it works. So it works simply by, let's say if the previous is here and the current is here, and we want to delete the number after the first position, the previous will point to the current of next, which is this pointer. So this will take this route. Alright.